Hello, this is Coding Gicha for full-stack developers. While backups are sometimes omitted, they are essential to protect valuable data from hackers, equipment failures, and data disasters. Data loss can even occur due to human error. Backups can be broadly categorized into on-site backup and cloud-based backup. On-site backup, a traditional backup method that backs up data locally within a company, is vulnerable to physical threats such as fire, flood, theft, and power surges. Managing backup data on physically separate tapes or disks incurs maintenance costs such as hardware purchases and labor costs to manage them. Furthermore, hidden costs such as hardware upgrades and replacement of faulty equipment can arise on an ongoing basis. Due to these costs, it's common to store backups of multiple web servers on the same disk, in the same server space, and in a specific path. Using the same disk not only increases vulnerability to physical threats but also leaves organizations vulnerable to hacker attacks. Backing up data to the same disk on the same server space is of no use when it's truly needed. Cloud-based backups are incomparably superior to on-site backups in terms of reliability, accessibility, and security. While costs can increase with the amount of data stored, using a Git repository can reduce this burden. Backing up to a Git repository automatically performs incremental backups, allowing for faster backups. My video on backing up server data explains how to use a Git repository for cloud-based backups. Systems built on-premise with third-party applications often have their own backup features, clearly demonstrating the problems and risks of on-site backups. I realized that the severity of the problem is so serious yet so widespread, leading me to create this video. This video explores the seriousness of backups provided by third-party applications based on real-life examples. I'll illustrate this severity through a third-party application actually delivered and used by a major Japanese manufacturer. This issue is not limited to Japanese manufacturers, it's prevalent in other countries and across various types of companies. Third-party applications, which are described as having a universal structure independent of the server environment on which the system is deployed due to their nature as packaged systems, also provide on-site backup. This structure backs up data to the same disk space on the local server where the system is installed. Furthermore, even this backup is performed within the path where the third-party application is installed. In other words, the backup data is stored back within the application itself. Perhaps this universal structure is just an excuse. Even the backed up SQL files are located within the third-party application folder, so simply moving the entire folder allows for a completely identical copy of the data used by the company. Although the application itself was originally provided by the vendor who delivered it, the data within it is the customer's valuable data, but it can be easily copied. Even the ID and password of the administrator account are registered identically or similarly in other companies' systems, and the administrator has super authority to not only manage the system but also look into all users' projects, so if you successfully clone it, you can easily look into all the information. Even though this structure allows for such easy data transfer, some may argue that it's difficult to actually extract data, as it requires accessing the server where the third-party application is installed. However, since this system is a web application, it must be accessed via a web browser over a network. As mentioned earlier, other companies' systems also have the same or similar administrator account ID and password, making logging in easy. This system contains excessive permissions and functionality beyond what administrators need. Administrators can export system data with the click of a button. The backup SQL file, related files, and uploaded data are all compressed and downloaded as a zip file. The downloaded zip file even includes a file containing the system's version information, allowing the user to create a completely identical environment to the customers as if the entire application's installation folder had been extracted. Exporting system data is a much more serious issue than backup issues. For security reasons, exporting and importing data should only be permitted when necessary to share the data with other systems. However, the system data is not used outside of the system itself, and the fact that it includes a backup SQL file means it serves no other purpose than replication. While I can't provide a detailed description of the system since it's an application delivered through a consulting engagement, the system is installed on the consultant's laptop. The structure of the system installed on the consultant's laptop and the system installed on the client's server are exactly the same, allowing for immediate replication of the client's data by importing the downloaded system data at any time. Furthermore, since the entire backup can be included in the application folder, the folder itself can be shared among vendor consultants. While the data management system may be used solely for consulting purposes for the client company, it's undeniable that it's a backdoor that can be easily exploited. If you want to securely manage your company's data, you should seriously consider implementing third-party applications that provide backup and system data export functionality or any suspicious features. If you're already using a system with these suspicious features, you should set a deadline and demand that they remove or improve all of these features. You should manage your data yourself, not rely on others. The web application architecture is so intuitive that simply dumping database data and backing up the folder that manages uploaded files is all you need. Creating these backup tasks as shell scripts and scheduling them allows for secure, periodic backups. Cloud-based backups are only effective when managed directly. No matter how much the vendor explains the necessity of backup and system data export functionality, allowing them will make your company's data unsafe. Vendor-provided backups are implemented programmatically, so they're often not periodic backups but rather backups performed before an event occurs. When you really need it, backups aren't there. If backups are required before a product update, you should run a backup shell script you've written yourself and then have the vendor perform the update. The vendor's best chance of direct access to the server is during a product update. Therefore, backups may have been performed only during these events. Even without a backup shell script, creating a database dump and copying related data is incredibly simple. Frankly, product updates primarily involve application modifications, not customer data modifications, so there's virtually no need to back up data. Even if the database schema changes occasionally, tables or columns are added, and data modifications are rare. There may be actual data migrations, but these are rare. It's fine to back up data only during these updates. You should request notification of updates involving data migrations. While you shouldn't hand over system data entirely to the vendor, even if you request it for tasks like data restructuring, you can provide selected data from the backup data obtained by running the backup shell script yourself. Therefore, the system data export feature should be removed. Although system data should not be handed over to the vendor in its entirety, even if requested to do tasks such as structuring the data, the system data export function should be removed so that it can be provided by selecting it from the backup data received by running the backup shell script directly. The problems with the system's backup and system data export functions may be just the tip of the iceberg. A system implemented this laxly is highly likely to have similarly lax implementations of other functions. Even if it wasn't exploited as a backdoor, the system had become increasingly entrenched in a Galapagos-like state. Web applications don't need to be dependent on the operating system, but because everything was tailored to the consultant's laptop, the web server was also limited to Windows, resulting in a Windows-only service. The system was a consulting tool that structured and managed client data. It also provided a function to output structured client data to an Excel file. While several modules already existed for the function to output search results to Excel, it was implemented using a vulnerable Excel macro. This appears to be the result of the server running Windows and the consultant's PC having been directly applied to an Excel macro created on the client's PC. For Excel macros to run, MS Office, which is mainly required on the customer's PC and not on the server, must also be installed on the server, so customers will easily recognize it. Using Excel macros not only increases the cost of MS Office but also poses significant security vulnerabilities. Excel macros pose potential security risks such as malware execution, computer system destruction, and information leakage. You should request the use of an Excel conversion program module. If using Java, this can be implemented using Apache POI, and if using PHP, it can be implemented using PHP Spreadsheet. You should request that this module be used instead of the vulnerable Excel macros. This system is also a consulting tool for structuring client data. I discovered that the consultants involved in structuring client data were having difficulty collecting and working with client data on their laptops, and that they were also using an administrator's PC. They had installed a web application on the PC and called it the administrator's PC. They even implemented a feature that allowed them to work on the administrator's PC and then mirror the results back to the server. Office spaces, rather than server rooms, are significantly vulnerable to security vulnerabilities in many ways. Furthermore, to ensure that the results from the administrator's PC were reflected in the server database, the server's database was configured to allow remote connections. Connecting to the database remotely requires additional security measures, but no such measures were taken. It's possible to block remote database connections and instead implement a single web application installed in the same server that uses two database schemas. After structuring customer data, the data is transferred to the corresponding schema locally on the same server. If the vendor is reluctant to implement this, the web application installed on the administrator's PC should also be managed by the server. Multiple web applications can be used on the same server by using different contexts or configuring multiple hosts. Vendors delivering third-party applications aren't actually concerned with security. If they're a consulting firm, they'll likely want access to their customers' data. Companies still rely on existing on-site backups or manage their data complacently simply because they're familiar with them and haven't encountered any issues in the past. However, when a data disaster strikes, they realize the need for cloud-based backup, but by then it's already too late. When implementing a third-party web application, simply checking whether it can be installed on a Linux server can ensure the safety of your company's data. If the product can only be installed on a Windows server, it may contain vulnerable Excel macros or other implementations that allow for the direct use of copied data on a consultant's laptop. Thank you for watching.